All right, welcome. Today we are going on a journey, a deep dive into the microscopic world that is you. We're going to talk about the fundamental building blocks, the tiny engines and master builders working 24/7 inside every single one of your cells to make you, well, you.
I mean, have you ever really stopped to think about it? What are you actually made of? If you look past the obvious stuff, the skin, the bones, the organs, what's down there at the molecular level doing all the heavy lifting? Well, that's what this is all about. Think of this as a guided tour of your own cellular makeup. We're going to meet all the key players one by one.
Okay, so where does our tour begin? It starts right here, in what scientists call the cellular pool. And I want you to picture it like a bustling, microscopic city. It's just jam-packed with all the stuff, all the components that life needs to actually happen. It's this incredible collection of, well, everything. And we're about to meet its most important residents.
So, our little tour is going to have 4 main stops, and at each one, we'll get to know one of the 4 major types of biomolecules. These are the true celebrities of your cellular world, the real power players that run the whole show.
First up, carbohydrates. You know, if your body were a high-performance car, carbs would be the gasoline. Simple as that. They're the most abundant organic substance out there in nature, and they are absolutely essential for powering literally everything you do.
And their main job? It's beautifully simple. Energy. That's it. The electricity that's firing in your brain as you're listening to this, the power you'll need to take your next step, it all comes from breaking down carbohydrates. There's no doubt about it. They are your body's #1 preferred source of fuel.
But of course, not all carbs are created equal. We can basically split them into 2 big groups. On one side, you've got your sugars. You know them, they're sweet, they dissolve in your coffee, they have that crystalline structure. Then on the other side, you have the non-sugars, like starch. They're tasteless, kind of formless, and, try stirring flour into cold water, they don't really dissolve. So a good question is, how are all these different carbs actually built? Well, it all starts with these tiny little guys called monosaccharides. The easiest way to think about them is like individual Lego bricks. They're the simplest, smallest possible unit of a carbohydrate. And just like Legos, you can link them together to build much, much bigger and more complex structures.
And here's our star player. This is glucose. It's the most famous one of those bricks we were just talking about. You've probably heard it called blood sugar. It's the simple sugar you find in stuff like honey and grapes, and it's the main fuel that's literally circulating in your bloodstream right now, powering your brain, your muscles, everything.
Okay, so what happens when you take a whole bunch of those glucose bricks and start linking them together? Well, you get what we call complex carbohydrates, or what scientists call polymers. The starch in a potato or the cellulose that makes up the tough walls of plants, that's all they are. Just massive long chains of thousands and thousands of those little glucose units all hooked together.
All right, time for the next stop on our tour. Let's talk about proteins. And if carbohydrates are the fuel for our cellular city, then proteins are, well, they're everything else. They're the workers, the machines, the communication lines, even the buildings themselves. They do pretty much everything.
And just like carbs are made of sugar bricks, all proteins are built from a set of 20 different building blocks called amino acids. A great way to think of it is like a 20-letter alphabet. Now, every single amino acid has the same basic backbone structure. But you see that R side chain part? That's the part that's different in each of the 20 letters. It gives each one its own unique personality and properties.
Now here's the really cool part. A protein's power comes from its shape. It's not just a random string of those amino acid letters, no way. It's this highly organized 4-step folding process. It starts with just the linear sequence, like a long piece of ribbon. Then, that ribbon starts to coil and fold into some basic shapes. After that, the whole thing folds up on itself into a super complex 3D glob. And sometimes, you'll even get multiple folded chains that team up to make the final machine.
Yeah, let's look a little closer at that second step, the initial folding. You can see the 2 most common patterns that the amino acid chain likes to form. There's the spring-like coil, that's called an alpha helix, and then there are these flat folded sections, which we call beta sheets. These simple repeating shapes are the absolutely crucial first step in building the protein's final complex 3D structure.
So, why do we care so much about the shape? Because the shape determines the job. And man, do proteins have a lot of jobs. They're enzymes that speed up chemical reactions, like the amylase in your own saliva that starts digesting your food.
They're transport vehicles, like the hemoglobin carrying oxygen in your blood right now. They're structural, like the keratin that makes up your hair and nails. They even defend you. They're the immunoglobulins that fight off infections. They are truly the jacks of all trades of the cellular world.
Okay, we're heading to our final stop now, and here we're going to meet a pair of essential partners, lipids and vitamins. These two are absolutely critical for things like long-term energy storage, building key structures like cell walls, and just making sure all the chemical reactions in your body are running smoothly.
So let's start with lipids. This is a really diverse group of molecules. We're talking fats, oils, waxes, steroids, but they all share one super important property. They are insoluble in water. They hate water. And this is actually their superpower. It's what allows them to form the protective outer barrier of every single one of your cells, the cell membrane.
I'm sure you've heard the terms saturated and unsaturated fats, right? But what does that actually mean? Well, it all comes down to their chemical structure. Unsaturated fats have at least one double bond in their chain, and this creates a kink or a bend. That kink prevents them from packing together tightly, which is why they're liquid at room temperature. Think olive oil. Saturated fats, on the other hand, have no double bonds. Their chains are straight, so they can pack together really tightly, which makes them solid, like butter. And it's really important to remember that lipids are so much more than just fats and oils. Take a look at cholesterol. It's a type of steroid. And yeah, I know it gets a bad rap sometimes, but cholesterol is absolutely vital for you. It's a key ingredient that gives your cell membranes the right consistency, and your body uses it as the starting block to build all sorts of important hormones.
And finally, let's talk about vitamins. These are the essential helpers. Think of them as tiny but crucial tools that your body needs but can't make on its own, or at least not in enough quantity. So you have to get them from your diet. And as you can see, they have very specific jobs. Vitamin A for your eyesight, vitamin K for blood clotting. And if you don't get enough, the consequences can be really serious, leading to things like scurvy or night blindness.
And that brings our tour to a close. We've met all the major players. So now let's kind of zoom out for a second and just put it all together to see how this incredible molecular toolkit works in harmony to build and run the amazing, complex machine that is you.
So look, if you take away just one thing from all this, let it be this. Each of these molecules has a critical role in your body's toolkit. Think of it this way. Carbs are your quick energy. Proteins are your builders and your do-everything machines. Lipids are for long-term energy storage and building walls. And vitamins are the essential little regulators that help everything run smoothly. You need all of them working together to function. And just to give you a sense of scale here, a little fun fact for you. The single most abundant protein in the entire human body is something called collagen. It's a structural protein that literally holds you together. It's in your skin, your bones, your tendons. It's the glue. It really drives home the point that you are quite literally built out of these amazing molecules.
So, that leaves us with a final question for you. Now that you've seen the toolkit, the fuel, the builders, the regulators, you can really see how it all connects back to the food on your plate. Your body is constantly being built, repaired, and powered by these molecules. So the question is, how are you going to choose to fuel it?